Good afternoon, students. This is video 2.9. The unit title is Logic Lines. Your objectives are, I can prove and apply theorems about angles, and I can use parallel lines to find measures of angles of triangles. Okay. The only IXL skill for the week is D6. And just so that you know, you will have a quiz redo tomorrow in class. That's right, a quiz redo. There was a mistake on your quiz 2.2, so you'll have a redo tomorrow. And your test 2 is on November 10th. That is 1 week from Monday. Let's go, flippers. The last video, you guys had quite a few things that you worked on and that you learned. So what we're going to look at today are the converses of those theorems and how to get started with making some really good proofs. So let's go. When we think about the converse, yes, a converse is basically if you take a statement and you flip it, right? So you're going to take the P and the Q and you're going to make it basically if Q then P. So that's basically what's happening with the converses of our alternate interior angles, alternate exterior angles, the consecutive interior angles, and the corresponding angles, okay? The converses of all those statements are true. We're actually going to look at what those statements would be right now. First one is going to be our if two lines and a transversal form alternate interior angles, are angles 3 and 4, alternate interior inside of these lines here, and there's a transversal. If that is true and those angles are congruent, so as long as angle 3 here and angle 4 are congruent, then that means that these lines are going to be parallel. These lines meaning M and N. Okay? So automatically as a result of these two angles being congruent in this situation, we have two parallel lines. So that is the converse of the alternate interior angles theorem. Number 2 is very similar. Now number 2 says, well, if, and go back up here again, two lines and a transversal form alternate interior angles that are congruent, then again the two lines are parallel. So here are alternate exterior angles. They are both congruent. So you would say angle 6 is congruent to angle 7. And then you would say these two lines are parallel. Now let's call these lines again M and N, M and T. So now we can say that that is true. And this will be called now the converse of the alternate exterior angle theorem. 3 clearly says if, again, two lines and a transversal form corresponding angles that are congruent. So here we have angle 5 and angle 8, and they are congruent. We'll have a statement that says that. Then the two lines are parallel. So that would mean here M and N would now be parallel because of these two corresponding angles that are congruent. Last but not least, we want to talk about number 4. And this actually, I want to say, is something we should clear up. The CIA, the consecutive interior angles, is a postulate. So this particular one is actually a postulate. So that means we don't have to prove it. You're lucky. It's one we're going to be using a lot. Anyway, if two lines and a transversal form CIAs that are supplementary, then the two lines are parallel. So here we have 5 and 7, and we'd have a statement that says angle 5 plus angle 7 equals 180 or are supplementary. Then we would actually say, wow, this is going to be true. So now we have the converse of the CIA postulate. Okay, so that is 1, 2, 3, 4 converse theorems and a postulate that we'll be using as a part of our repertoire now. The cool thing you want to take away from this is that all of these statements that we just wrote and we just kind of practiced are basically converses, and we know what converses are, and they're all actually true. Another theorem that I thought would be really helpful that we could use this semester. So let's just think about it. It's called the perpendicular transversal theorem. So what happens basically is if a line is perpendicular to one or two parallel lines, and it's also perpendicular to the other. So what would happen would be S would be parallel to R, and that's what this statement here says. So then we know that these two lines here are parallel. And then you'd have another statement that said S is perpendicular, that's that upside down T, to M. So if S is going to be perpendicular to M, then because S and R are parallel to each other, R is also parallel to M. So that's basically what this theorem says. So make sure you jot that one down as well, along with the example that goes with it. So now we're on to just talking about what are we using these theorems for. So being able to prove theorems is a part of the reason why we study geometry. And in addition, we will prove statements are true as well. So that's what we're going to be working on doing. We've been using a 2-column proof. You can also use a paragraph proof, which is often suggested. But we are going to use a 3-column proof method for our proofs this school year. A 3-column proof is an organized method to prove statements are true. And it looks similar to what we have here. We have a what, which is our statement, a why, which is the reason, and then the pictures in action. This is where you're actually going to work through your proofs. We'll also be using something called the sandwich method to make our proofs. Well, we will actually start with the top, which is usually our givens, and we'll have what we're trying to prove on the bottom, and then we will build all of the ingredients in the middle. And this is an awesome organic veggie burger of some kind with yummy, yummy ingredients, and that's how we'll work on it, always moving from top to bottom. To be really good at proofs, you need to remember what we've done before we started this, okay? So what you have here is a list, a beautiful table full of definitions, theorems, postulates, and properties that we've been working with that you will need to know in order to answer the questions in IXL Skill D6 and to do well on your Unit 2 assessment. So you want to think back to the definition of vertical angles. Oh, that's when they have those opposite rays. They're connected. That's not the same as the vertical angle theorem, which just says vertical angles are congruent. You want to remember what parallel lines are, complementary, supplementary angles, and perpendicular lines. You want to remember what these 3 theorems are. And again, remember I told you that the consecutive interior angles is a postulate, so you don't have to prove it, but you have to know what it is. Angle addition, segment addition, the equality properties. And notice these are in blue. That's because on IXL, these are called just plain old algebra. The only time they look for properties is when they're talking about symmetric, reflexive, transitive. Substitution does come up, so does congruence and distributive. So all of these here, again, you should have written down. And if you're not sure what they are, you want to attend a lunch and learn so that you can get review on it. We will give you a table like this in class, but you need to have this written down in your notebook. So example number 1 today says, state the postulate or theorem that proves line A is parallel to line B. All right, so I'm looking at number 1 and I see I have an angle here that are congruent. So it kind of looks like if I were to cut this right here, this would go right on top of it, meaning line A and line B, and they're in the same position. This is upper left-hand corner, upper left-hand corner. So I know that that is corresponding angles, but this is the converse because we don't know if the lines are parallel, but we do know that the angles are congruent. So we're going to say this is the converse of the CA theorem. 2, again, state the postulate or theorem that proves A and B are parallel lines. So I'm looking at the picture and I'm noticing that I have these 2 markings here that demonstrate that these 2 are congruent. So they are on different sides of this transversal, so that means they're alternate of some kind, and they are inside of these lines. These lines are not parallel yet, we can't say that, but they are interior, and we know they're angles. So that means in order to say that these 2 lines, A and B, are parallel, I would have to use the converse of the alternate interior angles theorem. Okay? Again, because I'm trying to prove that the lines are parallel, and I can only do that if I start with the angle information first. Number 3 says, given A is parallel to B, okay, we know they're parallel. Angle 1 and angle 8 are supplementary. This is what we need to prove. And here is our beautiful picture that they gave us. Thank goodness. And I've already started with my what, why, and my picture and my work. Remember, the what is going to reference to the statements. The why is the reasons. And then again, the pick work is just our notes that we're using to help us. So let's get started. First thing, part of my sandwich is that the top, so A is parallel to B. That was given to me. That's why. And the picture is that I'm going to add in those arrow markings on those lines just to make sure I remember that they are parallel. The bottom again for the sandwich, now I'm going to write in what I'm trying to prove, and that is that Angle 1 and angle 8 are supplementary. I don't know what the reason is, and I don't know what work I'm going to need at this moment. But I'm trying to get from knowing their lines are parallel to this statement. So let's put our ingredients in the middle. Notice right now that angle 1 and angle 5 are actually corresponding angles because I have two parallel lines cut by a transversal, and these are in the same position. And I just mark those angles with a little mark. Okay, so that's my step 2. Closer, but not 1 and 8. The next thing I've noticed is that angle 5 and 8 here make a linear pair, which means they're supplementary. So angle 5 and 8 are supplementary angles. The reason is because the linear pair is a postulate. Remember the table that I showed you earlier? And then over here I just drew a little picture to show me, again, that 5 and 8 add up to 180. Next statement, number 4, comes directly from number 3. If I know something's supplementary, I know that those two things add up to 180. So now I've written that statement out, and now this is looking kind of similar. So now I should be trying to think, well, what's happening and how do I get to finish my sandwich? This is very close. 5 and 8 and 1. What relationship do I see between them so that I can fill it in? Now, I just wrote a statement that says angle 1 plus angle 8 equals 180. Well, why can I do that? Well, I can do that because look back here. Angle 1 is congruent to angle 5. So now I just basically plugged in something up, and that's called substitution. The reason why I was able to write statement number 4, if you remember, was because of the definition of supplementary angles. I was able to go from the word supplementary to 180. Well, the reason I can now go back from something being equal to 180 to the word supplementary, which is my last statement, is again because of that definition. My 6th statement and my solution. Again, what you don't see over here are steps for 4, 5, and 6 under the sandwich because these were simple definitions and substitutions. Okay? Oftentimes when you have that, there is no picture of work because you know those definitions by heart. But when there are postulates involved, you definitely do have to write them. The problem for today is number 4, and it says complete the proof. Line VX is parallel to line SU. So we're not starting with parallel lines. We're trying to prove things parallel. And this is a problem for my Excel, so you've seen it before, hopefully. So let's take a look at it. The statement tells you that angle TWX is congruent to STW. Okay, so that's given and the things are marked there, so that's why we have given. And then it says number 2, it says angle RTU is congruent to angle STW. I have 2 sets of congruent angles. The next property, the next thing that comes up is the transitive property. And that tells us that TWX here is going to be congruent to RTU because of the transitive property, which clearly states that if A is congruent to B and B is congruent to C, then A must be congruent to C, and we can all see that. And now if you're looking at this picture, you're seeing that this angle is in the bottom left-hand corner of this set of lines and the bottom left-hand corner of this set of lines. And this looks kind of like corresponding. So we're trying to prove something, and that's right, that's what it is. We're going to numbers of the corresponding angles theorem. Because remember, we have angles that are congruent, and we're trying to prove that lines are congruent, and this does it. The converse proves the parallel lines. Is the secret hot question for you? Remember, IXL skill is D6. Do not forget that. It is D6. So what you have to do for this secret hot question is just fill in that one little blank. So you want to read through this proof, and the proof says, given that these two lines are parallel, so you know they're parallel, you want to determine, well, complete the proof that the measure of angle TWV plus the measure of angle STW equals 180. And you're trying to figure out what is step number 2. What is the reason why? What is the why? Why is this true? Okay, so make sure you figure it out using all the information that is given. See you tomorrow.